In this particular video, we are going to learn how to evaluate the determinant of a matrix and then use something called Cramer's rule in order to solve a system. So looking at this first particular problem, we are being asked to evaluate the determinant of a matrix. Now, the notation for a determinant looks like absolute value symbols, but it actually means determinant. So when you see those symbols around a capital letter, that's saying take the determinant of that matrix. And what you do is you're going to take the product of the terms from the top left to the bottom right. So if I multiply that together, I get AC multiplied by BD. And then you have to subtract the cross product of the terms that go from the top right to the bottom left. And so if I multiply those, that would be a 9AD multiplied by BC. Now, if you can simplify, certainly do so. Because multiplication is commutative, I can go ahead and put all those terms in alphabetical order. So I'd have A times B times C times D minus, I've got a 9, and I also have, when I put my terms in order, an A times B times C times D. So altogether, if you will, think of this as a 1 ABCD minus a 9 ABCD, then you are left with a negative 8 ABCD. Okay. Now, with Cramer's rule actually says if you want to find the solution for x, and there is a solution to the system, then you will take a determinant with respect to x, and you will divide it by what we call a basic determinant. And to find the value of y, you will take a determinant with respect to y divided by the basic determinant. So to start with, let's figure out what our basic determinant is. And the numbers in our matrix are going to come from the coefficients of our variables. So first, notice that our equations in our system are in alphabetical order. X is first, followed by y, and our constant is on the right-hand side. So you have to have your equations set up that way. So when I look at my coefficients of the x term, I notice that I have a 1 and I have an 11. So those are going to go in this first column to represent my coefficients of my x term. And then when I look at the coefficients of my y values, I have a negative 11 and a positive 2. So those are the numbers that are going to go in the second column. And you can label if you want, but you don't have to. But basically it's x coefficients in the first column, y coefficients in the second column. So once you set up that matrix, then you evaluate the determinant. So top left to bottom right, 1 times 2 is 2, minus 11 times negative 11 would be a negative 121. So simplify, when we subtract a negative, that's the same as adding a positive. So our value for our regular determinant is 123. Now, when we go in to figure out the determinant with respect to x, so that we can evaluate the value for x, what we're going to do is put our constants in place of the x coefficients. So when I look at my particular system, once again, you will notice that my constants are 53 and negative 32. So those are the numbers that are going to replace the x coefficients in the original D matrix. My y coefficients will stay where they were. So remember, my y coefficients were negative 11 and positive 2. So that is how you set up the matrix, and then you evaluate the determinant. So 53 times 2, that's going to give me 106. And then I say minus. And if I multiply negative 32 times negative 11, that's actually a positive 352. But we are subtracting, so when we take 106 and we subtract 352, we are left with a negative 246. So actually at this point, x is the value of your determinant with respect to x divided by your determinant. If we take negative 246 divided by positive 123, we see in this case that x has a value of negative 2. And so now to finish, to evaluate our determinant with respect to y, your x coefficients will go in the first column just like they did in this original matrix. So 1 and 11 were my x coefficients. And this time your constants take the place of your y coefficients. And so whatever subscript you have here, it's always the constants that is replacing that particular column from the original matrix. So when we're looking at d of y, your constants are replacing the y coefficients. And so my constants once again were 53 and negative 32. So now I go ahead and calculate my determinant. 1 times negative 32 is negative 32. And then I subtract 53 times 11, and that is 583. So if I take a negative 32 and I subtract 583, I am left with a negative 615. So my value of y is the determinant with respect to y divided by my determinant. So that would be a negative 615 divided by a positive 123. And that would tell me that my y value is equal to negative 5. And they're telling us to write your answer in the format of an ordered pair. So x always comes first. My x was negative 2. My y value is negative 5. And that would be the solution to that particular system.